next you write down rotating table. Rotating horizontal table or platform. Rotating horizontal table or platform. Rotating horizontal table or platform. Like this is the platform. This is the platform, correct? It is rotating like this. Okay, understood? So, how is the platform? Vertical or horizontal? Sorry. How is the platform? Tell me. Horizontal. But I will draw on board. Okay, board is horizontal for me. Understood? Board is horizontal. Suppose this is the table. It is rotating. It is rotating like this. Okay? It is rotating like this. So center is there. This is the center. So axis, you can call it axis also. It is rotating about this axis. So what is the angular speed? Omega. Angular speed omega. Now you put some coin here. Suppose you are putting some coin here. You are putting coin here. At what distance you are putting the coin? X. X distance. So it will fall. Suppose this is the coin. It will slide. See, if you rotate it, it will slide. See, look at the scale. It is sliding. When I am rotating, it is sliding. Correct? So it is sliding. So it is falling. It is slipping. Correct? It is slipping. Why? Why it is slipping? It is experiencing force. Where? What is the direction of force? Outward. So note down. Note down. When coin is placed at some distance, when coin is placed at some distance from axis of rotation or center, axis of rotation or center. Okay, you give me your rubber band, rubber you give me. Rubber, that is better. So it is so suppose this is the axis. Okay, now I am rotating it. Is it sliding? Is it sliding now? No, I am rotating it. Is it sliding? See, sliding or not sliding? Sliding. Now if omega is less, not sliding. Now I am increasing omega. Omega means rotation speed. More speed it will slide. See, you observe it will slide here. See, correct? So why it is sliding? Why it is sliding? Why it is sliding? Tell me. Why it is sliding here? Tell me. Which force? Centrifugal force. Okay, note down. Good. Centrifugal force. When coin is placed at some distance, coin is placed at some distance from axis, it experiences centrifugal force. what is the direction of centrifugal force? Away. Away from center. Away from center. So this is the direction of centrifugal force. It is a pseudo force. Okay, centrifugal force is a pseudo force. It is not real force. It is real force or imaginary force? Imaginary force. It is imaginary force. So the direction of pseudo force will be away. Okay, this is the direction of pseudo force. Centrifugal force. Now what is the downward force? Downward force. What is the downward force? mg. Upward force. Normal. And this one, this way, what is the force? Centrifugal force. So towards center, what force will act? Friction. Towards center, friction. Okay, note down. And omega is constant, note down. Omega is constant. So if it is not slipping, like I'm rotating it, it is not slipping, not slipping. So what type of friction? What type of friction? Yes. Static friction. So note down. Not slipping, or no sliding. No sliding. So friction and centrifugal force are equal. So static friction is balanced. Static friction is balanced with centrifugal force. Static friction balanced with centrifugal force. So static friction F is equal to centrifugal force. What is the formula for centrifugal force? mr omega square. So what is the radius here? Distance here? X. So mx omega square. Mx omega square. Okay, clear? Note down. No slipping, no sliding. So static friction is equal to centrifugal force. Okay. Now I increase omega. When you increase omega, see, omega is more. When omega is more, friction also more. When omega is zero, what is friction? Zero. Right now, what is friction? Zero. So as omega increases, friction increases. Note down. As omega increases, friction increases. Okay. So suppose now omega is less. Now omega is more. So friction is also more. Okay, like this. Now omega is very large. More omega. So at one particular omega it will slip. See? At one particular omega it is slipping. So why it is slipping? Tell me. When you increase omega, after certain value of omega, coin slip. Why? Coin will slip. Tell me why it is slipping? Correct. Good. Because mx omega square is greater than maximum value of friction force. So mx omega square is greater than mu s n. Understood? And what is the n value? N value mg. Okay. N is mg. So mx omega square is greater than mu s mg, cancel. So what is omega square? Greater than mu s g by x. So omega is greater than square root mu g by x. Note down. So this is the formula. So if you want coin to slip, so omega must be greater than this. Omega must be greater. What if omega is less than or equal to this? So coin will not slip. Coin will not slip if mx omega square is less than or equal to mu s n. So mx omega square is less than or equal to mu s mg. So omega square is less than or equal to mu s g by x. So omega is less than or equal to a square root of mu s g by x. Okay, clear? Note down. Now you solve this question. Coin is placed at distance of coin is placed at distance of 1 meter from axis of rotation of horizontal table. So what is given? X. Angular acceleration of table. Angular acceleration of table is two radian per second square. If coin slips after 10 seconds. Coin slips after 10 seconds. Find coefficient of static friction. Find coefficient of static friction. G value is given, small g value 10. Okay, note down. Small g value is 10. Now angular acceleration is constant. So alpha, angular acceleration means alpha. So you can use omega is equal to omega naught plus alpha t. Initial omega you can assume 0. Initially when coil is placed at distance of 1 meter from axis of rotation. Okay. So what is the initial speed? You can take 0. Assume initially table is not rotating. Table is not rotating. Okay. Table is not rotating. So this is the table. So what is the initial omega right now? What is omega? 0. Now omega is increasing. Okay, omega is increasing like this, like fan. So omega increasing like this. Understood? Fast. So omega is increasing. So initial omega 0. So what is omega? After time t, what is omega? Alpha t. Alpha is given 2. And after what time coin is slipping? 10 seconds. So what is the omega at that time? 20 radian per second. Understood? So it is slipping. Coin just slips. Coin just slip. So I can use this formula. So omega is equal to square root of mu s g by x. And x distance is given. What is x distance? What is the distance from axis? 1 meter. So solve. So omega you got 20. So 20 is equal to square root of mu g by x. So 400. Take a square on both sides. So 400 is equal to mu g by x. X is 1. So what is mu? 40. Mu is 40. Mu is 40. Mu is 40 means it is highly rough. It is highly rough surface. Highly rough. Mu s, what is maximum value of mu s? Infinity. Minimum value? 0. If you put Fevicol here, quick fix. Now put it. So what is the coefficient of friction now? Infinity. Fevicol. It will be perfectly stick. Okay. It cannot slip because mu s is very large. If Fevicol is not good quality, so after some time it will slip. Understood? You increase the speed, omega you increase, it will slip. Okay, done. Okay, finish. Done. So one more question you can write. Coin coin is kept on rotating table coin is kept on rotating horizontal table. It just slips. It just slip. It just slipped when kept at 1 centimeter. It just slipped when kept at 1 centimeter from axis. If omega is doubled, are you getting this question? Initial omega is something. So at what distance you have to keep so that it will just slip 1 centimeter. Now omega is doubled. Now at what distance you keep? Now at what distance you put coin? At what distance you put coin so that it slip? At what distance you put coin so that it slip? Now, so what is relation between omega and x? Use this. So mu is constant, g is constant, correct? So mu g is constant. So what is the formula? Correct. So square on both sides. So omega square is equal to mu g by x. So omega square is inversely proportional to x. Understood? Use this formula. So omega 1 square by omega 2 square is equal to, tell me what is the formula? Omega 1 square by omega 2 square is equal to x1 by x2 or x2 by x1? x2 by x1. Very good. So use this. Omega square is inversely proportional to x. If x is less, omega is more. So see, if this is the axis, now x is less, so I have to rotate fast, very fast I have to rotate. Okay, see, then only it can slip. Now I am not able to rotate that fast. Okay, very fast you have to rotate like this. If you keep object here, x is more, so less omega. When x is more, omega is less, so it will slip very easily. It can slip very easily. Are you getting? Less omega only it is slipping. So omega less, x more. Understood? Inverse relation. So what is the answer? Tell me. So omega 2 is doubled. Omega is doubled. So omega 2 is 2 times omega 1. So what is this ratio? Ratio omega 1 by omega 2 is 1 by 2. So 1 by 2 square is equal to x2 by x1. Understood? So what is x1? 1 centimeter. So what is x2? Calculate. 1 by 4 is equal to x2 by 1 centimeter. So what is x2? 1 centimeter by 4. So how much? 0.25 centimeter. Okay, clear? 0.25 centimeter. Note down. So this omega 1, omega 2 clear? Are you getting or not? This formula you memorize. In your formula diary also you write down. So formula diary is important. Are you maintaining formula diary? Huh? How many? Tell me. Raise your hand. Those are maintaining. Okay, good. Formula diary is very important. Only formula. Only formula. Okay. Only formula and some important points, critical points. Like plus, minus, up, down, like that. Critical points. Any special cases are there? Okay. If there is some special cases like block on block, case 1. What is the formula for case 1? F max. Tell me. Block on block. First case. Remember? Force is acting on lower block. What is the formula? Mu s. M1 plus M2. G. Correct. Very good. Second case. What is the formula? Okay. M2 by M1 into G. Correct? Okay. Fine. Good. So block on block. Okay. So now we have one formula here. This is the formula. Relation between omega and x. X is the distance from axis. X is distance from axis. Next. Now we are doing banking of road. We can do. Note down. Banking of road. This is the last topic of friction. Okay. This is the center. So your car is taking a turn. Your car is taking a turn. So when your car is taking turn, note down, note down. When car takes turn, okay, left turn, right turn, left turn, right turn. Okay, okay. Suppose it is taking left turn. So for some time it is in circular motion. It is circular motion. for some time, for some time duration, it is in circular motion. Are you getting or not? When you are taking left turn, like you are going north, now you want to go west. So here to here it is circle, quarter circle, correct? Suppose you want to take U-turn. If you want to take U-turn, you are going north, now you want to go south. So here to here it is circle. What type of circle? Full circle? Half circle. So half circle it is there, correct? Sometimes roundabout is there. Roundabout is full circle, correct? You have seen drift. Sometimes some racing, they do drift like this, circle, circle, circle. Lot of heat, smoke is coming from car, right? So drift, that is circle drift. So, fine. So centrifugal will be outward. Suppose V is, speed is V. So what is the direction of centrifugal force? Outward. Centrifugal force, understood? So now when you see from horizontal, okay, suppose this is the road, car is going like this, car is going like this. So downward, what is the force? Tell me, downward. mg. Upward, normal. Centrifugal force, away from center, centrifugal force. So the car will skid, but car is not skidding. Why? Friction, because friction is acting. What is the direction of friction? Towards center. Friction is towards center. Static friction, not down. Static friction towards center. Static friction towards center. Okay, clear? So if road is good, if road is good quality road, so friction will be more. Friction will be more. So it is not easy for car to slide. It is not easy for car to slide. If road is not good, it is a slippery road. It is a slippery road. Slippery road means like monsoon is there. If monsoon is there, wet, road is wet, mud is there, muddy road. Monsoon, what happens? Road is muddy, so friction is more or less? Less. So friction will be less, but centrifugal force will be more. So car will skid, correct? Car will skid. So car do not want to skid. What should be more? I don't want car to skid. More. Static friction should be more. Good. So note down. Note down. So this is known as unbanked road. It is horizontal road. Okay. Suppose this is the road. This is the road. This is the outer edge of the road. This is known as outer edge. And this is known as inner edge. This is known as inner edge. Okay. Road. Two. What you call boundary? What you call boundary? Outer boundary, inner boundary. Okay. So same level. Same level means it is unbanked road. Note down. It is known as unbanked road or level road. This is known as level road. Okay. Note down. Unbanked road or level road. Both are same level. Now this is known as banked road. This is known as banked road. I will come to that. So note down. To avoid slipping or skidding, to avoid skidding, what is the condition? Tell me, what is the condition? Centrifugal force must be less than or equal to maximum friction. Which should be more? Friction should be more. Skidding tendency is outward. Now what is centrifugal force? Tell me. Formula? mv square by r. mr omega square or mv square by r. Okay, both are same. And what is maximum friction? Mu s n. N is mg. N is mg. R is the radius of circular turn. So V square must be less or equal to mu R G. Note down. V square must be less than or equal to mu R G. So V must be less than or equal to square root of mu R G. Okay. So note down. So this is the safe speed. So your speed should be less or equal to this, not more than this. If speed is more than this, it will skid, car will skid. If speed is more than square root of mu rg, car will skid. Car skid. Now I am drawing two diagrams. You tell me which has less radius. This is road 1 and this is road 2. Which has less radius? A small radius. Road 1. Road 1 has a small radius. Road 2 has greater radius. Correct? Now solve one question. Mu s is given as 0.4. R is equal to given 400 meter. G value you take 10. Find maximum safe speed at turn. Find maximum safe speed at turn on road. You are taking turn on road, level road, unbanked road, unbanked road. Okay, unbanked road. Note down. Level road. Tell me. So what is the formula? Mu rg. Apply mu rg. Mu rg. Solve. What is the maximum safe speed? Maximum safe speed. Okay, calculate. Tell me. Tell me. Square root. Mu s is 0.4, r is 400, g is 10. Find maximum safe speed. What is the answer? So 0.4 into 400 into 10. How much? 0.4 into 10, how much? 4. 0.4 into 10, 4 into 400. So this is 1600. What is the square root of 1600? 40. So 40 meter per second. So if your speed is up to 40, it is okay, safe. Up more than 40, it is not safe. Okay. If more than 40 meter per second, so car will skid. Car will skid, slip. Okay, car will slip. Okay, clear? So note down. So this is known as level road. This is known as level road. Level road means unbanked road. Unbanked road. Okay, clear? Level road. Friction is acting or not? Friction is acting. Static friction acting. Okay, note down. Next you write down if road is banked, if road is banked, road bank means like this. So outer edge is lifted, outer edge is lifted. Are you getting? How you see road? You have seen road, correct? If you go outside, you will see road. Road is like this. What is the color of road? Color of road? Black. So this is black road. You see this is the road, correct? This is the road, correct or not? So now it is taking a turn. So this is the outer edge. This is the outer edge. Outer edge. This is inner edge. Inner edge. So this is the outer edge. The inner edge. It is lifted. Okay. So outer edge is lifted. So when you see horizontally, it will look like this. What is the height of lift? How much lifted? H. And what is the width of rod? W. So this is known as angle of banking. This is known as angle of banking. Okay, angle of banking. Note down. So what is tan theta? What is tan theta? H by W. Note down. H by W. So mostly you will see in hill stations. Okay, observe this in hill roads. When you go to hill, there is a sharp turn, correct? Sharp turn. You know any hill nearby where you can see sharp turn? Where? What is the name? Spelling? Huh? K K A J K A J. Okay, I know one point. Kohli Hills. Have you heard about Kohli Hills? Huh? Have you heard? Kohli or not Kohli? Kohli near Madurai. Namakkal to Madurai. When you go Namakkal to Madurai, Namakkal, you know? Huh? Namakkal, right? Salem, Namakkal, Madurai, Kohli Hills. Okay, you will see like this roads. Roads are like this. Okay, understood? So you take turn. Okay. So turn is there. So it is roads are banked. This is known as banked road. Now car is coming like this. So you draw diagram like this. Now this is the car. This is the car. These are tires. Okay, I am seeing from behind. Car is going like this. Is the number plate. Okay. So this is the center. This is the center of turn. Center of circular motion. So radius of circular motion. Mg downward. Normal will be up or inclined? Normal. Normal will be inclined. Good. So real force, real force. Now imaginary force. What is that imaginary force? Centrifugal force. Centrifugal force. mv square by r. mv square by r. Now you take components. So how many forces total? 1, 2, 3. How many forces? 3 forces. Now break it. Find component of mg and mv square by r. is theta. So what is this component? Tell me. What is the component? Sine or cos? Cos. Okay, so this is the along the plane. Take component along plane and take component perpendicular to plane. Okay, parallel to plane, perpendicular to plane. Okay, parallel, perpendicular. So break these two. Normal already perpendicular. Don't break it. These two you have to break. Now break mg also. What is this component? And what is this angle? Theta. Okay. So this component cos, this is sine. This is mg cos theta, mg sine theta. And this is normal. This is normal. Are you getting? Now car has tendency to skid here. Okay, car is going like this car is going. So like this, it has skidding tendency here. It will skid here. So friction at where? Friction down. So this is the friction. Okay, understood? So now balance these two. Balance for no skidding. For no skidding, what is the condition? Tell me. For no skidding, mv square by r cos theta must be less than or equal to friction plus mg sin theta. Correct? Are you getting? So this is the situation. Note down. Now what is the minimum value of friction? Minimum friction, tell me. 0. Maximum friction, tell me. Tell me maximum friction. Mus n. Mus n. Now put f equal to 0. When f is 0, what is the value of V you are getting? Tell me. When f is 0, what is V? When f is 0, tell me. When f is 0, what is the V? mv square by cos theta is equal to mg sin theta. Cancel. So what is V square? Okay, V square by Rg is equal to tan theta. So theta is equal to tan inverse V square by Rg. So when friction is 0, remember, when friction is 0, so no friction. No friction means it is not like it is a smooth surface. No, it is not a smooth surface. These two are balanced. Mg sin theta and mv square by r cos theta balanced. These two forces balanced. This is balanced with this. Are you getting? Suppose you have a block. You have a block, right side you are exerting 1 Newton. So what is the friction? Friction will be 1 Newton left. Correct? But suppose let left side you are exerting, right side 1 Newton, left side also you are exerting 1 Newton. Now how much friction? Now friction is 0 because no external force. So when these two are balanced, so friction is 0. Okay. So note down, friction is 0. So what is the condition that friction is 0? What should be speed? What should be speed? Tell me. V square. Tell me what is V square? Rg tan theta. So V will be square root of Rg tan theta. So friction is avoided. Okay, no friction. Friction is avoided. You call it no wear and tear of tire. No wear and tear of tire. Tires will have long life. Okay, tire has long life. If you want long life of tire, friction should be 0. Okay, so note down. So unbanked road, what is the formula? Unbanked road, level road, what is the formula for V? Must be less than or equal to, correct. And for a banked road, what is the formula for V and friction 0? Friction 0, banked road. What is the formula for V? Correct, root of Rg tan theta. Correct, good. Root of Rg tan theta. Now next we are at on last point. If now we have written already, see you have written here. What is the minimum value of friction? 0. Now what is maximum value of friction? Mu s n. So now start from here. If friction is maximum, when friction is maximum, tell me what is the formula, what is the relation? F plus mg sin theta must be greater than or equal to mv square by r cos theta. So what is the friction? mv square by r cos theta minus mg sin theta. So if now this is constant, this is constant. Now V, you are increasing V. If V increases, friction also increases. Friction also increases. But friction has a limit. What is the limit of friction? Limiting friction. What is the limiting friction? Tell me. How much is limiting friction? Mu s n. And what is n value? Come to this diagram. What is n value? What is n value? Tell me. Mg cos theta plus mv square by r sin theta. You can note down here only. Mg cos theta plus mv square by r sin theta. Note down. Now put it here. So mg cos theta plus mv square by r sin theta. So when you increase the speed, friction also increases, but limiting friction is this. So what is the maximum speed you can drive when friction is maximum? So put this here. So mu mg cos theta plus mv square by r sin theta is equal to mv square by r cos theta minus mg sin theta. Okay, clear? Now cancel, cancel. So mu cos theta into G plus mu V square by R sin theta is equal to, now this is the maximum speed, okay, V max square by R cos theta minus G sin theta. So take this left side. So mu cos theta G plus G sin theta is equal to, now V max square by R common cos theta minus mu sin theta. Are you getting? Cos theta minus mu sin theta. Now divide both sides by cos theta. Divide both sides by cos theta. What you get? Divide by cos theta. Tell me. Mu G plus G sin by cos tan theta is equal to V max square by R. Now divide by cos here. Cos by cos 1 minus mu tan theta. So G common, now G common, mu plus tan theta divided by, take this here, 1 minus mu tan theta is equal to V square by R. So what is V square? What is V square? RG bracket, what is numerator denominator? Mu plus tan theta and divided by 1 minus mu tan theta. Okay, clear? So this is the formula. Note down. So V is equal to maximum speed is equal to square root RG of this. So this is the formula. Okay, remember this formula. Okay, clear? So note down. It is easy. Okay, just practice it. Carefully you practice. So now you have three formula. Unbanked road. Unbanked road, what is the formula? Tell me. What is the safe speed? Maximum safe speed? Root of mu RG. Banked road without friction. Friction 0. What is the speed? Root of RG tan theta. Good. And third formula is this. Okay. Friction is maximum. Banked road friction is maximum. So V is equal to this. RG mu plus tan theta upon 1 minus mu tan theta. Okay, three formula. So when you read the question, first you identify which case. How many cases? How many cases? 3 cases. Okay. So identify which case. Unbanked road, banked road. If it is banked road, zero friction, maximum friction. Okay. All formula different. And how to find tan theta? Tan theta you can find like this. H, W, width is W. Sometimes it is railway track also. You have seen railway tracks. So railway tracks also they can give. One rail is lifted like this. Rail, okay, rail. Now train is going like that. Train taking turn. Train is taking turn. So this is H, this is W, this is theta. Same formula you can use, same formula. Okay, H by W. Okay, clear? So just remember this. So note down these three formula. Now solve this question. So come to page 282. Page 282. Question 93. Solve. What is question 93? Tell me. Unbanked road. Unbanked road means Formula 1 or 2 or 3? Formula 1, 2, 3. 1. Formula 1. Tell me. Formula. Mu r. Correct. So maximum speed. So solve this. Solve the question. Radius is given. What is radius? 60 meter. What is the maximum speed? You have to find maximum speed. So solve. Mu is given. Mu is 0.75. Radius is 60. Gravity value 10. This you can take 0.75. You can take. You know 0.5 is 1 by 2. 0.25 how much? 1 by 4. 0.75 how much? 3 by 4. What is 0.2? 1 by 5. 0.33? 1 by 3. 1.33. Okay, like this. 4 by 3. So this 3 by 4 into 600. 600 by 4 is 150. So 750. No, 450. Square root of 450. Now 450 can be written as 9 into 50, correct? 9 into 50. 50 can be written as 25 into 2. So what is the answer? Square root of 9? 3. Square root of 25? 5. Square root of 2? 1.4. 15 into 1.4. 15 into 1.4, how much? How much? 15 into 1.4, how much? You will get 21. Huh? 21. Okay. Okay. So 21. Okay, clear, done. Okay. So this is over. Now next, 92. Sorry, 94. 94 also like this. What is 94 question? Motorcycle riding at what is the speed? What is the speed? 94 kilometer per hour. How much? Convert kilometer per hour. 1 kilometer per hour. How much? 5 by 18. 5 by 18 meter per second. Okay, so 36 kilometer per hour means 94 question. 36 into 5 by 18. How much? 10. So V is 10. So 10 is equal to square root of mu rg. So 100 is equal to mu rg. Now mu is given or what? Mu not given. Mu is 0.2. Mu is 0.2. So you have to calculate radius. Least radius. Least radius. V V square must be less than or equal to mu rg. That means mu rg must be greater than equal to V square. So R must be greater than equal to V square by mu g. So what is the minimum value of R? What is the minimum value of R? V square by mu g, correct? So V square by mu g. So we can use this, or you can use this also. So 50 R is equal to 50 meter. Okay, 100 by 2, 50 meter. Now 95. Solve 95. Ninety 95 which case? 1, 2, 3 which case? Circular curve highway designed for traffic moving at 72. Radius of curved path is 100. What is the correct banking angle? So mu is given or not? Question 95, mu is given or not? Mu is given or not? Not given. So it is second case, second formula. Mu not given means no friction. So no friction. So what is the second formula? Second formula, tan theta V square by Rg. Okay, find tan theta. What is tan theta? What is V square? Now what is V? 72 into 5 by 18. Okay, how much? How much? 20? 20, right? So V square how much? 20 square. R radius, what is radius? Radius given 100 meter, G value 10. So 400 by 1000, 400 by 1000. So 0.4, okay? Or 2 by 5. 2 by 5. So tan theta 2 by 5. Tan theta 2 by 5. So what is theta? Tan inverse 2 by 5. Okay, clear? Okay, understood? Now 98, solve 98. Now solve 98. 98, 100, 101, 102, 106. 106 is coin question. Remember coin question? Slip. 109. This 289 NEET 2016 question is there. Page 289, question 22. Okay, finish all questions now. Page 268, solve example is there. 51, 52, 53. Okay, then step up exercise is there. Page 272, 11, 12. Page 272, 11, 12. Page 272, 11, 12. Okay, now you solve this. How many questions? 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12. Okay. Okay, finish these 12 questions. Then we'll continue.